Hello everyone, I am Dr. Abha Kumari, Assistant Professor, Mathematics Department, Nirmala College. Today we discuss about the differential equation. In this book we have taken the chapter differential equation with constant coefficients. In this chapter we will discuss about the particular integral of trigonometric function. For this we will take the question as solve d2y by dx2 plus 4y equal to sine 2x or cos 2x. For the solution part, the solution of this question contains the two parts. First is the complementary function and the second part is particular integral. Complementary function we have discussed earlier. So we'll just find how can we calculate the complementary function of this given differential equation. First we take the auxiliary equation. The auxiliary equation is m square plus 4 equals to 0, where m is the value of dy by dx. By solving this, we get the value of m square equals to minus 4, and this implies m square equals to 2 square I square, and this implies m equal to plus minus 2i. Therefore, its complementary function is given by CF equal to A cos 2x plus B sin 2x, where A and B are any two constant. Now for this particular integral, we will take the Pi equals to sin 2x divided by d square plus 4. Here we have written d square plus 4. Here d is taken for the value d by dx. Since it is a d square by dx square, that's why we have written here d square, and here is a 4y, so plus 4. And the right side part is sin 2x, so the sin 2x is in the numerator of this function. So sin 2x divided by d square plus 4. As we have discussed earlier, if there is a trigonometric function, then d square can be replaced by minus times a square, but we cannot use here this property because while putting this value, the sine 2x, here is sine 2x divided by d square equals to minus 4 plus 4 and equals to 0. Since the denominator equals to 0, so we cannot proceed for the solution. That's why this property cannot hold here, and so we will find the solution of this differential equation as the imaginary part of e to the power 2ix divided by d square plus 4. Here we have taken e to the power 2ix, since e to the power 2ix is equals to cos 2x plus I sin 2x plus I sin 2x, and I sin 2x is the imaginary value. That's why we have taken here imaginary part of e to the power 2ix divided by d square plus 4. Since in the question we have given the sin 2x, if it is a cos 2x, then we will write here the real part of e to the power 2ix divided by d square plus 4. But since it is the sin 2x written here, that's why we have taken the imaginary part of e to the power 2ix divided by d square plus 4. Now this is equals to the imaginary part of e to the power 2ix divided by, as the property, if there is a exponential function, then the power of this exponential function will place the value of d as d equals to d plus 2i. So we will use this property here and we will write e to the power 2ix divided by d plus 2i whole square plus 4. On solving this bracket, we have the value e to the power 2ix divided by d square plus 4di minus 4 plus 4. Now this is equals to the imaginary part of e to the power 2ix divided by d square plus 4 di, since minus 4 and 4 getting cancelled. On proceeding this solution, we have the imaginary part of e to the power 2ix divided by 4di. We have taken the 4di as common, and so we will get the value as e to the power 2ix divided by 4di 1 plus d squared divided by 4di. We have taken 4di as the outside because if we will not take the 4di common, we will take d square common, then we get the infinite solution. And here we have to find an exact solution, and that's why we have put it here 4di as common. So this is equals to the imaginary part of e to the power 2ix divided by 4di bracket 1 plus d squared divided by 4di whole inverse into x to the power 0. Here we have put it this x to the power 0 because there is no function left here, and this is the value of 1 is here. That's why we have written here x to the power 0. Now the imaginary part of e to the power 2ix divided by 4di bracket 1 minus d squared divided by 4di plus dot 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 x to the power 0. Now imaginary part of e to the power 2ix divided by 4di. Now solving this solution, we have x to the power 0 minus, since there is a d square and here is a x power 0, that is equals to 1. So is d means the differentiation of this function. So while differentiating x to the power 0, that means 1, we will get the 0 here, so 0. And on proceeding this way, we will get the next rest values are also equals to 0. So this is equals to the imaginary part of e to the power 2ix divided by 4i, and d is taken inside this bracket, so 1 by d x to the power 0. Now this means the integration of x to the power 0 means integration of 1. So we will get here x. So this is equals to the imaginary part of e to the power 2ix divided by 4i into x. Now imaginary part of minus I squared divided by 4i cos 2x plus I sin 2x into x. The minus I square is written here because we have the value here is plus. So we will write it as minus I square. Now imaginary part of minus I divided by 4, I is getting cancelled. Now cos 2x plus I sin 2x into x. Now this is equals to imaginary part of minus I cos 2x divided by 4. Then this has minus I square sin 2x divided by 4 into x. While solving this bracket, we have the imaginary part of minus ix cos 2x divided by 4 plus x sin 2x divided by 4. Now the imaginary part of this whole bracket is equals to the minus x cos 2x divided by 4. So this is our particular integral of this given differential equation. So the general solution is written as complementary function plus pi, that is equals to a cos 2x plus b sin 2x minus x cos 2x divided by 4. On the same way, we can find the solution for d2y by dx2 plus 4y equal to cos 2x. Thank you.